Hello everyone, I am Rathinam from Wildlife Multitech Dr. Rangarajan, Dr. Sakunthala Engineering College. I am handling game development. Today we are going to see about Unity single player and multiplayer games. Unity. First of all, we are going to see about Unity. Unity is the powerful game engine that allows the developer to create both single player as well as multiplayer gaming experiences. We will explore the networking features offered by the Unity, delving into the fundamentals of client server and peer-to-peer architecture, implementing the basics of multiplayer functionalities and synchronizing the game states and handling latencies and designing scalability, multiplayer experiences. Whether you are a recent Unity developers or just starting, this guide will provide you the necessary knowledge to create the engaging and high performance multiplayer gaming experiences. Introducing Introduction to Unity networking features. Unity networking features allows as a developer to build the robust multiplayer experiences with ease. The engine provides a suite of tools and APIs that simplifies the process of setting up a networking infrastructure, handling client-server communications, and synchronizing the game states across as a multiple clients. From basic lobby systems to complex real-time interactions, Unity networking capabilities yeah, offers a comprehensive solution for creating engaging multiplayer games. At the heart of this Unity networking is a high-level APIs, HL API, which abstracts the low-level details of networking and allows the developer to focus building their gaming logic, but they remain intersect logics. And API provides as a component to scripts that handles a task such as player authentication, message serializations, and driven networking. Driven networking is being made. And next of all, we are going to see about networking architecture of client server versus peer-to-peer. Client server, peer-to-peer, and hybrid approaches. Client server architecture, client connected to the central server that manages the game state and coordinates the interactions between players. This approach offers several benefits, including centralized control, data security, scalability. The server acts as the authoritative source of ensuring that all clients are synced and preventing cheating or data tampering. In client server, that is a central server, that authority that maintains every game states and data to the each client that takes part in this multiplayer gaming experiences. In peer-to-peer system, peer-to-peer networking, on the other hand, involves a direct communications between the client without the need of central authority. This architecture is often used in a game where low latencies and decentralizations are crucial, such as real-time strategies of fighting games. Peer-to-peer network can be made challenging to implement, but it can be offers better performance and reduces the server cost. In terms of use as a client server, we have to maintain a server that's cost is high. In peer-to-peer system, that is maintaining this latency is the uh, only task that is not made in this peer-to-peer network, but it is a better for performances. In hybrid approaches, many modern multiplayer games employs is a hybrid approach. Hybrid approach combining the elements of both client server and peer-to-peer. This allows the developer to leverage the strength of each model and create a more flexible and scalable networking solutions. In networking, we want to it's a multiplayer game, so we want to develop the each player to consume the gameplays and mechanics and strategies and data and level ups. Everything can be serialized to the each players when maybe take part in this gaming network. And in client server, the server cost is the only problem that is to be maintained. And the peer-to-peer, it is a peer-to-peer. It's connected to the each server, each clients in this architecture that can be made through this concentrations. It is a challenges, and both in hybrid model, we make up to the positive sides of client server and peer-to-peer. We take it in a single part of it, and take part in it. That is the main thing to be interpreted and more flexible and scalable for our networking solutions that can be made in it. Next, we are going to see about implementing the basic multiplayer functionalities. To get started with the multiplayer in Unity, the developer must first set up the necessary networking infrastructure. We have already seen about the networking infrastructure, that is client server, peer-to-peer, and hybrid. We can select this one networking infrastructure. This involves the creating networking managers, configuring the connection settings, and defining the game network objects and player perhaps. Uh, and Unity HL APIs provides a set of components and scripts that handles this task, allowing the developer to quickly and easily establish extra networking foundations. Once a networking setup is complete, the next step is to implement the basic multiplayer functionality such as joining a game, swapping players, and handling players inputs. Unity network behaviors class serves as the base for the networking game objects. It provides as a method of for synchronizing data, invoking remote procedures, and manages the life cycles of network entities. In Unity, that gives us enables us HL API provides us a components for script that takes part in the networking objects in it, and scripts are already inbuilt. We can use it of this network to connect to the networks and players that can be made in this gaming experiences. We manage as a lifetime for this network. First is key multiplayer functionalities, players farming and management. How these players is get part into this and how to maintain and manage the players in to take part in this gaming is called management, and handling players inputs and actions. In every player in this every player that takes part in the game in a single game, then we have to manipulate and handle this every player's inputs and its actions. Uh, if, for example, it's a fighting game, it takes part in a 12 players, or like a Free Fire or PUBG game, the set of players that can be in this game will be each input of the player. Every player that takes part in it has a unique actions, and it's everything and being take part, and synchronizing the game is another major thing. And synchronizing the game, every stage, every actions that can be performed, every event that can be performed in this, that can be synchronized to the every each and every player in the gaming game, according to coordinating game progressions and events. That is also each of the inputs from the player is can be handled, and the progressions of the game and the event that can be performed in this gaming, that can also be progressed to the every partner to the every players in this game was mandatory for this all the players that can be take part in this journey. And synchronizing game state and player actions. How we can go for synchronizing the game state and ensuring that all the clients that has a consistent view of a game state is the critical aspects of building the successful multiplayer experiences. Unity networking systems provide several mechanisms for synchronizing data, including remote procedures called network variables and state synchronizations. And Unity has a wide range of steps and libraries to perform this Unity multiplayer and single player gaming experiences. We have to synchronize the every game state so that each and every player actions can be serialized and synchronized to the every player that takes part in this game. Remote procedure calls allows us a client to invoke the method or networking game objects in Unity that it takes part in objects in each game object that will be triggered, and the actions can be performed and the game state will be thrown accordingly, and update the game states. Network variabilities on the other hand automatically synchronizes the variables of the values of the variable across the clients, ensure the changes are immediately reflected in the game world. If you take part in this game, single game world, multiple players who take part in it, and each and every moves can be immediately reflected in this game world. First one is player movement, and second one is projectile firing, and third one is game movement. And game movement synchronize the player positions and rotations using network variables, ensuring that all clients see the same player movements in real time. If you are in a real time, particular time, then it has a 12 player game like that. And the 12 player, let's take part the different actions in it, and every actions can be synchronized with each other. And second, projectile firing use RPCs to trigger projectiles firings on the server that synchronizes the projectile states and behavior across all kinds. If it's a projectile, if projectile is in, of the projections and perspectives of the players and single that can be made in it and seen. If it's the long distance or it's a night view, the projectile views can be fired for the each player that can be take part in a multiplayer gaming experiences. In game development and in game events, coordinate game events such as scoring points, activity, power-ups by including the RPCs and update the game state on the connected clients. In every player that attack can be made, that can be a particular scoring points and activating the power-ups and many power-ups methods and everything can be updated in the game state on the connected that is a 12 player game. It's not connected to the 12 player, and it's every player that connected into the single game world that can be updated in various manner. And we are going to see about handling latencies and lag compensations. Latency is nothing but a delay, which can be delays can be handled. One most performed, the delay can be handled, or it can handle the lag compensations. One of the key challenges of multiplayer game is dealing with network latency and lags. Network latency can introduce an inconsistency of the game world, leading to the issue such as delaying inputs, wrapping, rubber banding, and Unity networking system provides several techniques to mitigate this problem and ensure the smooth and responsive multiplayer experiences. If you're giving to the input, that can be some networking delays, that can be the moves can be updated minutes of usage as added. Some delays can be updated, some lags of is updated in this, and that can be corrected as predictions and interpolations, lag compensations, and reconciliations. Predictions and intervention predicts as a player movement and others actions based on the client input, then uses interpretations to smooth transitions between the predicted and actual state received from the server. To make the delay from a particular input that given by the client or a gamer, then it can be futurely we can predict by their client moves, and that can be before that it can be predicted, and the actual values from the servers can be related and manipulated, and then gives us output to the client immediately to avoid the latency in the gaming. Lag compensation adjusts the timing of events and the actions to the account for networking latency, ensuring that all clients see the same output recording regardlessly for their connection quality. Based of their connection qualities that can be each for the same outcomes regardlessly for the players that can be taken part in a multiple gaming. Reconciliation is a reconcile decision between the client predicted the states and server authorities, allowing the consist of view windows. And reconciliations of the states can be reconnected to the server, and once the network is not at all that can be maintained, then game out of this to the game, then they can be rejoined in this game due to this network latency. Then it can be the state, the current real time of the state can be viewed to that player, and they can be take part in this actions that can be made in this reconciliations process. and designing for scalable and multiplayer experiences. As the number of players in this multiplayer game increases, the networking infrastructures must be able to handle the growing demands. Designing for the scalability is a critical aspect for building successful multiplayer experiences in Unity. Serverless architecture, player instancing, performance optimization, rigorous testing. Serverless architecture exposes serverless or cloud-based networking solutions that can automatically scale and accommodate more player without the need for dedicated server infrastructure. We can go for a server infrastructure that can be costly, otherwise it can be maintained properly. Then the delay in this or a problem in this server that cannot be accessed at the time. Then go for serverless electronic structures when we can use it of in its various aspects and use it of for anywhere from this. And player instancing, implementing the player instancing where the game world is divided into a separate instances that can be hosted from a different server, allowing for a large players counts and reduces the network load. In network, we can in one single network, it's a limited set of players, set of players that take part in it. The player can be increased and this the latency and this everything can be delayed. So we can set like a sort of instance, separate instance and different aspects of it given, and then it can be reduced in it and network latency, and we can obtain the greater performance also. Performance optimization optimizes networking performance by reducing the frequencies and amount of data being transferred, leveraging the compression techniques, and employing the load balancing strategies. Uh, and rigorous testing throughout the test multiplayer systems under the various conditions, including the high player counts and network latencies, and ensures this handles the results of the particular gaming experience throughout this multiplayer gaming. And we can see about the debugging and optimizing the multiplayer performance. Building a robust and performance multiplayer games in Unity requires a combination of effective debugging tools and optimization strategies. Unity networking systems provides a range of utilizes and techniques to help the developer identify and address the issues that may arise during the development and deployment of their multiplayer experiences. That is networking profiler, lag compulsion debugging, network serialization optimization, scalability, and testing. And first of all, we are going to see about networking profiling. Unity networking profiling allows the developer to visualize and analyze the networking traffic, identifies the bottlenecks and packet losses, and other performance related issues can be updated in this network profiling. And log compulsion debugging. Unity network systems includes tools for debugging lag compulsions, enabling the developers to understand how the game is adjusted for the latency and ensure there is a consistent player experiences. In networking serialization, optimizes serialization network data by minimizing the amount of information transmitted, leveraging compulsions and techniques, and utilizes the most efficient data types. And scalability testing conduct through stress test and load testing to the multiplayer system can handle the expected number of players without the degradations in this performance. In this slide, we are seeing more about the Unity single player and multiplayer gaming experiences. When the multiplayer gaming experiences, we want to give the game logics and level ups to this each player that can be take part in this gaming experiences is most important aspect of this multiplayer gaming. Then Unity provides us various libraries and tools for developing, as well as easier way to develop a multiplayer or a single player game in Unity. Unity is very much used and affordable, and also very much used in the developer fields as well as for the gamers. In the game field, the various multiplayer games where now we are going to use various multiplayer games is more more used in this nowadays, and this types of games can be evolved and in this field of game development. Free Fire, PUBG, that are really the greatest aware of in this time of this world. So just we can conclude this from this various how to control this networking, and that can be the most important aspects in this multiplayer gaming experiences. How the latencies from the network latencies can be maintained, that is the key difference and key possibilical changes that can be happened, and that can be handled in a smooth way, that then the gaming experiences of multiplayer gaming is was amazing. So we can go for multiplayer gaming experiences to the each and every player that can be take part in it, that can be nicer and to be viewed in this. uh, and thank you for this. Thank you.